said, we're going to look at YOLO algorithm. YOLO algorithm is one of those dictation algorithm. It has various versions. It's used for object dictation and it's very easy to use. It has what is called transfer learning toolkit. YOLO algorithm is Although before we go into the YOLO algorithm, let's at the agendas for the day. An overview of YOLO algorithm, the tasks that are performed by YOLO algorithm, the NVIDIA toolkits, and then the major advantages of YOLO algorithm for this particular slide. Then we have another slide where we discuss how the algorithm itself operates. So, what is YOLO algorithm? Like I said earlier, YOLO algorithm is a machine learning, or better put, is an artificial learning model. And you know what a model is? What's the difference between an algorithm and a model? Who can tell us the difference between an algorithm and a model? Yes, who can tell us the difference between an algorithm and a model? Any volunteer? Any volunteer to tell us the difference between an algorithm and a model? Yes, Bamo, tell us. Thank you.
Yeah, just want to try. I think
Yeah.
the algorithm is the step of those of the instructions that are used on data sets to make up the model, and the model is the actual design that is used now to perform the that it is meant what that it is designed for.
Exactly. You're right. An algorithm are the step-to-step instruction used to build a model. Then when you apply a data set, when you apply an algorithm on a data set, you build a model. Okay? But before we say that an algorithm is a model, there should have been series of training on that algorithm. So when we say that YOLO algorithm or YOLO algorithm is a model, it is actually a model. It's just like you remember the last project you did. What did you use? Yes, what did you use the last project we did? What's the name of that software? The cat we did. What's the name of the application, the software we used to build our chatbot?
Dialog flow.
Dialogue
Dialog
flow.
flow. So dialog flow is a model. It is not just an algorithm because it has been pre-trained. So all you need to do is just to give it your data, following the instruction, then it gives you the required output. So YOLO is also a model because it has been pre-trained, and these are the tasks it does. It chooses k-means, it does training. It also, you know what we mean by training. It trains a data set you've given to it. Then it will evaluate the model, or rather it will evaluate the output of the data set you are expecting it to produce for you. Then it can easily inference. Then it can prune. When we say pruning, it's trying to refine the output of the the output of the model it has built. to give a better output. And then another task is that after training your model or after training your data set, it can export it and you can see what it has trained for you. Check someone. Good morning, how are you? You have to turn on the projector if you're using it. So please hang on. Someone is in the class. Sorry for the interruption. I have to carry everyone around along. It's not easy to leave the home to be in school. So let's connect to the projector in class so that those in class can be part of it. Is it on? See how it works. When we talk about YOLO algorithm, the major component of YOLO algorithm is what we call the NIVDIA. Or what is this NIVDIA? NIVDIA is a model or the toolkit that is used to build the YOLO algorithm. In the summary, that's what I can attest to that. It is a toolkit for building YOLO algorithm. And basically, YOLO algorithm is used for computer vision. Computer vision, like we said when we started this class, we said that there are various classification of artificial intelligence and machine learning. Computer vision is part of it, where we can identify things, where computers can identify things, just like the eyes of a human can identify something. So computer vision is that aspect where a computer can be used to sight something, process it, and then produce an output or make judgments based on what it has seen. That is an aspect of artificial intelligence. So YOLO algorithm is a combination of various pre-trained model. So it will help you when you give the YOLO algorithm your data set, it will be able to give you an output. And what kind of output are we looking at? It's going to dictate all the images in that mode, in that all the images in the picture you have given to it or in the graphical image you have given to it. You can give it uh, you can give it a video, you can give it a graphical image, and it will be able to identify the various components that make up that image. So basically, it uses deep learning, and you don't need code because there are already existing codes. We have different versions of the YOLO algorithm. So let's go on. So still on this NVIDIA framework or the NVIDIA model, the NVIDIA model is used to fine-tune models for computer vision. And the use cases are objects like identification, it will identify objects, it will classify image, segment image. When it comes to agriculture, this could be used to identify diseases. It can also be used in different other applications like in security to identify, you know, the when you place a camera. So the camera identifies the various images. So it is this YOLO algorithm, although YOLO algorithm is not the only one, but that's the most simplified artificial artificial intelligent model that is used these days. We say that the NVIDIA framework uses a pre-trained conventional conversational AI model to fine-tune models for conversational AI, and the use cases are like voice detection, natural language processing like in chatbot. So apart from the one we use for our projects, there are so many natural language processing models that are available. You can also add new class to a model that has already been trained. For instance, if you have if you have a video and you have an updated version of that video, this NVIDIA can help you to add and update the output based on the new update you have sent to it. It can retrain a model to adjust to various use situations. So based on what you are looking for, it can always train a model for you. So it has also what we call pruning feature. This pruning feature helps to modify and improve the efficiency of that model it has trained. So if it trains as the more data it has, the better the output of the model it's training. You can find this NVIDIA toolkit from this website we have here. And we said that the NVIDIA toolkit is a mountain of data. When we talk about mountain of data, we are talking about it has used so much data set, big data, to train the model, the machine learning model or the AI model. And instead of you to build your model from scratch, all you need to do is to use what it has before, and then you just impute your own inputs, like your video or your graphic image. Then you now modify it to tailor to your needs, just like we did when we were building the chatbot. So the NVIDIA Toolkit is a low-code implementation of the NVIDIA Toolkit. It's very, very fast, relatively, because when you talk about image processing or video processing, they take a lot of computational effort. But with the NVIDIA or the NVIDIA Toolkit, it's a little bit faster. You know, one of the difference between machine learning algorithm and deep learning algorithm is that machine learning algorithms are faster, while deep learning algorithms are somehow slow. They are slow because they need a lot of computational power to process the images or to process the data set. Another difference between machine learning algorithm and deep learning algorithm is that deep learning algorithm requires very huge data set for you to be able to build a model. But machine learning algorithm, you have different algorithms in the machine learning that can use very small data set, and they will also build a good model for you. For instance, when you're working with Bayesian network, you don't need so you don't if you have small data set, so it will be advisable for you to go for Bayesian network. So, but for this NVIDIA framework we are talking about, it uses deep learning processes to build its model. And it is based on TensorFlow and Python. How many of us have heard about TensorFlow before? Have you heard about TensorFlow before? PyTorch. I think could remember vividly that in this class we have done some of those libraries, machine learning libraries, and TensorFlow and PyTorch are part of those libraries we have looked into in this class. So, in all, or in summary, the NVIDIA toolkit is a pre-trained model that have a prior and artificial intelligence knowledge, and you can now use it to customize your own training to suit your need. Here are some of the advantages of using the NVIDIA toolkit. One of them is that it easily trained the model. Since we say it is low code, what we mean it is low code, it requires very little code. And you can train your model using Jupyter Notebook. Another advantage is that, excuse me, is that it developed very accurate to a very high extent. In fact, since the inception of, you can go and read it up, you can go and read up about the YOLO algorithm. Since the development of YOLO algorithm, it has gone through various stages of improvement from one version to another. The one we will apply for the practical session is the version 3. We have version 4, version 5, version 6, version 7. I don't know if it has gone beyond version 7, but I know we have various versions. But for each of these versions of YOLO algorithm, they have their own drawbacks. But the most stable of all is version 4 and version 3. There are certain things you will not be able to do in version 3 and version 4, but you can do them in version 5 of YOLO algorithm. But when it comes to stability of an algorithm, version 3 and version 4 are very, very okay. Another advantage of YOLO algorithm is it improves inference. By improving the model inference, it can go beyond personalization and get up to 4% or 4 times performance. What do we mean by this? One, when it starts the training, it will keep improving itself. The more you train, the more it improves itself, and it will give you a performance that is better than what it used to be, beginning from the first training of the data set. So let's look at the second. And then another advantage is that it's very easy to deploy. When you build your model, you can easily deploy it because it has a very good application interface with other applications. So when you build model for voice, model for vision, like the one we're going to build, and other AI applications, it is very, very easy for you to deploy it into various applications. So let's go into, and that should be all. So let's look at this yellow algorithm itself. How does it work? Like I say you only look once. That's the full meaning of YOLO algorithm. You only look once. YOLO algorithm is used for, first of all, image classification, then image localization, then image dictation. And what is different between classification of image, localization of image, and dictation of image? When we talk about classification of image, when you give or when you impute an image to a YOLO algorithm model or the YOLO model, it first of all tries to classify the different images in that input you gave to it. For instance, it will classify this as a car, and then this part as trees. So it will classify the images into whatever image it should be based on the training. That tells you that YOLO algorithm must have been trained with various cars, anything car, trained with trees, trained with any image at all, building, houses it can find. It has already pre-trained images of those. So it can classify it based on the type of image it has identified. Then the image localization, when it identifies an image like this, it will localize that image by drawing what is called a bounding box. This is a bounding box. It draws this bounding box to localize each of the images it has classified. Then you can see here, when we talk about dictation, it will dictate various images here. Here, it just classified this as image. Oh, there is an image, an existing image here in this one. So it will draw bounding box. Now, when it comes to dictation, it will now localize, dictate the various images. It dictates this as an image. It dictates this other one as an image. It's also supposed to dictate this tree as an image. If there is a person here, it will dictate. So in one image or in one graph or video you give to it, it will be able to dictate the various images or identify the various images in that particular graph or picture you give to it. That's how it operates. So now we're going to look at what we call, this is called bounding box, like I said in the previous slide. So when it sees an image, it will draw bounding box on that image and identify that image and classify it to wherever it belongs. For instance, it classifies this one as what? As a car. And it will classify this as a tree. And it will draw this bounding box around it. When it does this, the next thing it does, it will train it. This is the model, the convolutional neural network, and the TensorFlow and PyTorch. They are all embedded here. It does the training and then gives us an output. This output is referred to as softmax. Now, in this output, you have these various images it has dictated here. Like this would be, let's say, output. Most times in mathematics, we normally use y to denote our output. So this can be y1, this can be y2, this can be as many images as it's able to dictate in whatever graph you have given to it, or graphical input you have given to it, or video input you have given to it. It will identify all the images there and give them y1, y2, y3, or whatever name it pleases to give it. Then when it detects an image and classify an image, what happens? During this process, like what we saw in the previous session, like this output. What happens in this output? For it to be able to come up to identify this as a tree, to identify this, now, for every YOLO algorithm, for every image it dictates, it has an output. For every image you give to it, it has an output, and that output is denoted with Y here. It can be anything. So we have various classifications. For here, it has car, tree for C2, and then person for C3, a human being for C3. So for this particular image in question now, the output of this image will have these parameters. For every image classification, you have 8 parameters. The PC is the presence of an image. That's what PC means. Then the BX, BY, BH, and BW is the bounding boxes of that particular image. The value for the BX is, this is the X value, this is the Y value, this is the height. That's X as in length, width, length, height, and the breadth of that image. So this, it draws this bounding box around that image to identify the length, the breadth, the height, and the width of that image. So when it does that, That is the first thing it does before it will now start doing the training. Then the next parameter will now be the various images that it has identified or not identified in a particular graphic image you give to it. So for this, it's going to be, so it's for this particular image, the C1 is going to be the car, then the C2 is meant to be a tree, then the C3 is meant to be a person. So now for this particular image, this is a general representation of what happens when you give it an image. So for this particular image, the Y will be 1 for the PC because it's present. Then the BX versus the values for all these BX, BY, BH, and BW will be presented here. These values will be presented here, this part, to fill on this parameter. Then it's going to dictate this image, the presence of this image, to what extent is the prediction accuracy of this image. Here it is telling us that the prediction accuracy has represented here, it has 98% confidence that it is a car according to this representation. Then for others, like the tree, it is 0.1. It's not sure that there is a tree here, it's still looking at it. Then the 0.0 person, it has not even seen anything that looks like a human being here. So for this particular image here, this is the value of the Y. Then it goes to another image. For instance, look at this image here. You can see that this image is almost empty. There's nothing here for the YOLO algorithm to dictate. It's not trained to dictate a road because it's not necessary. Otherwise, it would have been able to identify this as a road. So here, the Y for this image, the values of those 8 parameters we talked about, the PC, the BX, the BY, the BH, the BW, and the C1, C2, and C3. Once the first one here, that is the presence of an image, is 0, every other value becomes 0 because there is no bounding box for it to draw, and other things are 0. So this image is an empty. If you use this and you give it something like this, it will give you a 0 because there's no image for it to dictate here. Now, once you give the YOLO algorithm an image, what it does, it withdraw bounding box for all the images, and it divides them into various grids. Basically, it divides it into 9 grids, if I'm not mistaken. So it divides it into 9 grids. For every image you give to it, or every input you give to it, it draws various bounding, divides it into various grids. So for this grid now, it will try to identify what are the images in this grid. It will try to identify the values of this Y, the parameter. Is there an image for this particular grid? So it will extract this grid and try to work on this grid. If you look at this grid, if YOLO algorithm is not trained with a mountain, it will not dictate this. It will see it as an empty grid. The same applies to this particular image. It will see this as an empty grid, empty, empty, empty grid. That is why here you see the Y is what? 0. And once Y is 0, like the P1, the PC is 0, that's present of a coordinate is 0. Every other thing becomes 0 because there is no coordinate for it to draw. And the same applies to all this one. It's not trained to identify any of this, so it will see it as 0. Now for this particular image, you can see that this car falls into these 2 grids. The car falls into these 2 grids. So what it does, it will draw a bounding box on this car. And now it will now calculate Based on this bounding box it has drawn, it will now calculate the relationship between this particular bounding box it has drawn and this grid here. So it will do the same for this other side. This bound, it will draw this bounding box or this grid here and this particular bounding box. So it will do an internal computation of this, of all the grid where this image has fallen into, to be able to identify the presence or absence of this image. You can also see that this particular image fell into two grids, this other grid and this other grid. But this image here, this third car at the back, falls into this grid. So when it's identifying, when it does the computation, it will calculate it based on the relationship between the bounding box and the grid. So that's how it does its own computation to be able to give you an output. The details of this, we don't really need them as per se, but it's just good for us to have an understanding of what all this is all about. I think that is this. So let's quickly go to, do we have any question before we go to the practical side of it? Let's try to something else. Any question? You only look once, not you only live once. Okay, so in the essence, all right, in the essence of question, let's go on. So let's go to the, I hope you guys knows how to go about this Google Colab. Have you started running the codes I gave you? I gave you codes. We have done a collab practical before,
But you didn't share the data set, madam.
but you didn't request. I didn't know that I didn't even share. And you guys didn't
No,
even bother.
I remember requesting and you said you're going to put on plan, but I think you
Ah,
forgot.
wow. That means you've not even tried any run. You've not tried using the Google
Me,
Colab.
I tried using Madam, but I was getting an error. I even invited you to. I sent a link to you that you can maybe check the error I'm getting, but I didn't get response.
Let me check. Should be on the. Where is my mail? This particular. Let me check. The account I use for my collab, I don't really visit it regularly. So if you send me a code or a question on that account, in which, where did you send it to? I'm not sure it's in this account. This is my collab account. Like I told you, and you need to create a separate account for collab because it's an account you usually share with people. They will have access to the email. I didn't see anyone. Where did you share it? Is it on Cavendish email?
Yes, I
Bamo.
used. Yes, I used.
Cavendish.
Yeah, I used my student email to sign up on Google Colab. Then after what I got some error. Then I just shared it to you.
I didn't receive, I can't remember receiving, I can't remember receiving an email in that regards. Probably I saw it and just, let me check. Okay, What is this?
Yeah, it's the one.
From sklearn.model logistic regression train. Value error, we should be ideal. I will check it up, but I will check it up and revert to you after this class.
All right, thank you.
So let's go to the collab. So at least that means, let me go back. That means you know how to import your data set here, and then you know how to play around with the collab. I always preferred collab to Jupyter Notebook because collab is always online. Though Jupyter Notebook is also online, but for collab you can easily collaborate with others at the same time in real time. I'm not sure if that privilege is available in Jupyter Notebook. You guys should know better. So let's go to, this is the YOLO algorithm. Okay, and Daniel, you said I didn't share the code. So where did you get the code you use or the data set you use? Bamu.
Yes, I got from client. They were both uploaded.
Because I know the codes are there on Planet. Or is it from last year you got it from?
No, this same year.
Because I know I shared the codes. Maybe you didn't check. Daniel, you are accusing me
Yeah,
of
for
it.
I
Huh?
always don't know I have
Huh?
the data sets which are not the correct. Of course you can download those data sets,
You
but
don't
that
have
was
the,
a particular one. No,
this
I'm
particular.
saying
Mm.
the clan you have probably other different data sets which are also I use when I'm practicing. But for that specific one, I looked for it. It's
This
not.
advert sales. This advert sales is there.
I'll
Mama,
be
where did you get the advert sales? I want to get it right. Maybe I didn't share or I shared. I don't know. Where did you get the advert sales data set?
It was on client, the same place where you uploaded the codes. The data set was just next to it.
Yes, when I load code, I normally put the data set side by side to it so that when you download the code, you can download the data set and run your code. Maybe you didn't check very well. So to go and check again, it should still be there. I didn't remove anything. So this is an introduction to the YOLO algorithm. We're going to be running this algorithm and we have an image. Out. This algorithm takes a while. Let me remove this. There is, or it has, I've run it several times. So you can see, as powerful as this algorithm is, see the short code we have here, because the code has already been cloned by Alex B. Darknet, which we copied from this particular website. and paste it here. So it has been cloned. So all the everything has been computed behind the bar. All you just need to do is to ensure that you follow the instruction and give it your data set and start running. So let's try this algorithm. And this is my image, or rather my video file, which I have imputed. This is my video file somewhere here, video 2 points. So whatever be the name of your video file, I'm not going to give you this video file, but probably you just look for any video file from internet or from anywhere that is not more than 2 minutes, 1 minute video file, because it takes a lot of computational effort to load this video file. So it depends on the type of laptop you are using. So let's go in and start and see how this works. Let's start from this part of the code. From Google Colab, okay, from google.colab, import drive. Why do we need to import drive? We're importing drive because this Alex V, this Alex B darknet is coming from our Google Drive. Where is this? Okay, it's coming. Sample data. It's not here. I'm searching for this darknet. It's not here.
Madam, it was cloned inside user local could have been.
Yes.
User
Okay, inside the user. Okay, but I can't
user
find my
folder.
user. Yeah, I'm looking for the
It is
user
down.
down.
Down. User
This
folder
one.
there. Yeah. The
Sure.
local. Local.
Okay. Okay, from the distance.
Then coulda then been.
Okay. Yeah, you're right. Yeah, so what I just did was to copy the path and paste it here. So let's go. So now from Google Colab, so we have to import the drive. That is the reason we have to use import drive and not import file. You know, since we have a file, we are running from our drive, we need to use the import drive. But the file itself we are going to upload, the video file we are going to upload is not in the drive, it's on my local disk. So let me run this. Let me remove it. Let me run this. So it's asking me to connect to Google Drive. And this is the one I'm using. And I'll ask it to allow. So now I want to mount the Google Drive to my Colab. So while it is running, yeah, it has mounted successfully. Now we have to make sure that the Tesla KB graphical processing unit is mounted because it's 12 GB. But most times it doesn't run for me. It's not working for me. So let me try something. Let me see if it will work here. Because if it will work, it will make my code run faster. Instead of using the CPU, the central processing unit, it should rather use this. So let's try if it will work. So I go to runtime and change my runtime to GPU. It's already set to GPU. Normally by default is there, but when I wanted to run this code, I have to set it to GPU. So maybe you try to set yours to GPU. Yours might not be like this, but whatever it is, just select the hardware accelerator type to GPU. Okay, then let's run this. So it's running now and it's using, this is why I like Google Colab. Colab will use the updated version and it's running with NVIDIA SMI, this particular version of CUDA, 12.0 of CUDA. So it's okay, it's running. So the next is to clone the darknet GitHub repository. The GitHub repository is the main NVIDIA toolkit itself. So for us to do that, we have to go to network, to this particular environment and copy this file and paste it in your Colab. So let's run this and paste it in your drive. So let's run this. Now and what are we trying to do? We are trying to connect to ensure, this is what Daniel was trying to explain. They even check it. This is what Daniel was trying to escape. This is where this particular file is resident. So what we are trying to do in this particular part of this code is we are trying to connect the operating system with this particular clone. So we're going to clone this using this path. So import OS, then we say os.environment, then path plus and equal to this path. We have to change the directory to darknet, then we'll get git clone this particular code. So let's run this. So it's cloning, and you know what cloning means. It's completed. Today is fast. So I get my runtime actually changed to GPU. But sometimes it can be very slow, and when it's running on my CPU. So it has cloned very fast. The next is to install the GSS or the GCC -4. So we have to install that. All these are part of the code. So just run this. By the way, unable to locate this file is also unable to locate this file. But it's functioning. I'll try to find out why it's not able to locate this GCC file. So let's continue. So go to the darknet folder, enable the GPU, then compile everything. So go to the night. That is what this particular site is all about. So here is going to create a new file for us. So here it's trying to compile the computer vision package, and this is it. To take a while, depending on the speed of your system. Then you get the YOLO weight file. This YOLO weight file takes more computing time than all these other ones. So to get the YOLO weight file, you use this particular code. So here we are using YOLO version 3. You can use YOLO version 4. You can use any YOLO version, but you have to be careful. about the so it will take a while. While this is going on, okay, it has finished running. So let's run this. So this is where we define the type of YOLO, the version of YOLO algorithm we are using. So we're getting the weight file. It's quite fast today. So it's completed. Then the next is to get the working directory. So we now have to transfer to the directory where we have our file resident. The input file I want to use is in my drive. It's in my local directory. So, and the name of this file, okay, let me get this first. Working directory. So it's loaded. Then this time I'm going to upload my input file. So from google.colab import files, uploaded is equal to anything. You know, this can be anything, just the variable equal to files.upload. Since I'm using my file, you see what I'm saying? So let me upload my file. And the name of my file is what? Video2.mp4. So it's an mp4 file. So let me start by running this. Then it will request for this file. So it's requesting for the file. I need to click choose file. So it brings me to my system where I have to locate the file. This is the file, I guess. This is an mp4 file. So make sure that this file name is the same with what you have here to avoid error. So it's loading my file. So now that you're going to write physical exam and physical CAT, that means the mode of you will not be doing project-based exam or project-based test anymore. So all those research you normally do and do projects, so it's not going to work. This implies that you're going to be more critical when you are looking at some of these codes. Anything I'm explaining in a code, there are some things I don't even bother to explain to you in code because they are very complicated, so I don't bother you about those. But the little things I take time to explain in the code are very important, and these are areas I can ask you questions in test or in exam. So you have to take note of those important things. Why should we load a file? Why should we use import.files instead of imports? Instead, why should we use import files instead of using import drive? And if we are using import drive, what should be here? So all these little things I normally explain, you have to take note of them. Are you for this class? Excuse me, are you part of this class? Can you excuse us? You may hold on, let me take attendance.
I did get you
Mm.
very well in the format you're going to be saying, because you said that since because this one is going to be a practical base, but you said that you don't want to be a practical thing whereby you have need to do anything, but you just need to sit down and maybe ask you so small question. So I'm worried how or maybe how the format you're going to be sending to us. So that we can maybe able to answer or maybe pass your exam.
Yeah, for CAT and exam, since we are doing physical CAT and exam, there are little questions, very questions that are very demanding. When I mean demanding, when I'm teaching, there are certain things I pay attention to if we are using code. Some of those questions I ask you in class, why are we doing this? Why are we not doing this? Why this and not the other way around? Those are the areas I will focus to ask you in exam. You discover that when I give you code or when I'm explaining a code, there are things I intentionally neglect. We just run those side of the code. I don't even say anything about those codes. Those sides could be very complex for you at this level. So I don't even bother you with that so you don't get confused. But the little part of that code that I know you must need, and sometimes it could be changed. And if there's any change in it, it will affect the efficiency of the running of the code. You see me place emphasis on those areas. Those are the areas that I might want to examine your understanding on. I ask more or less applied questions. I don't ask you to go and cram something. So I need you to really understand, then you'll be able to apply the knowledge. So, for instance, the code, this this prediction cells problem. This imports pandas as PD. I can write a code and I ask you to correct that code. So now I have import pandas as PD. I can intentionally write import pandas as PD. And inside my code, instead of using this PD.read, I'll use another something else to represent it, and I'll ask you that you should find out what is the error in this code. So if you don't know the reason why we're using this panda as PD here and why we're using this PD here, you will not be able to understand it. So these are the little things. Now here is from Colab, Google Colab, import files. Why are we importing files and not Drive? In this other one, we imported Drive. So why are we importing files there and not Drive? So these are the little things that could come up when it comes to tests or exam. I don't know if you get my code. Okay, like now I've also explained to you why we use print dataset.shape and print dataset.head. Why? Why are we using head here? Why are we putting 10? Why didn't we put 7? If we put 7, what happens? So these are some of the questions you need to understand. Why, when you see a code, you should be able to identify what that code is all about. You should be able to also explain what the code is all about. If I'm asking you a question that has to do with code, and if I'm asking you questions that has, hello, are you with us? What is that? If I'm asking you questions that are not connected to code, I will expect you to apply the knowledge we have taught. Like if I want to ask you a question on YOLO algorithm, you don't expect me to ask you what is YOLO algorithm. You know I won't do that because I know you might cram it in your head. But I'll ask you questions that will enable you to understand, to apply the knowledge of your YOLO algorithm to solve that problem. And it's what I know you should know. It's not something that is beyond you. So that is it. You need to pay attention in the class. I don't know if that is clear. Daniel, I guess it was Daniel that asked this question. Is that clear?
It is. It is. Thank you.
All right. So we're going to call it a day now. Bamo, I'm going to attend to your issue and get back to you.
All right, thank you so much.
Thank you for coming.